Hello everyone, Channel Technical Agronomist Matt Nelson here to do part 2 of our video year in review. And today we're going to be focused more on that middle time frame of the year. So looking at July and getting into August. And as you can see, we had weather come to play really the largest factor during this period, right? Two different wind events in July here through central Iowa, both came down the Highway 30 corridor. Very hot, very dry, stressful conditions, which carried through pollination, but really the impact that had depended on your planting date. And then as we got into August, we saw really two halves to the month. We saw hot and dry conditions early, and then cooler conditions later, and that brought some moisture along with it. And with that, we got some increased disease pressure. So that's really what we're going to be focusing on in this video. So as we get into July, obviously we start to see corn rootworm feeding. Our larvae really start to hatch and feed in June. That's a GDU-driven process, but really in general, the damage was a lot lighter than we expected to see across most parts of the state. Here you can see a map of the pressure from 2022, and really the pressure was a lot lighter than we expected. Obviously, if you were in west central Iowa or in eastern Iowa, you still saw lots of feeding. The question I've gotten a lot of is, what did we actually have a lack of pressure, or did we have pressure but we didn't see it? And I tend to think it's probably some of both. In general, we didn't have the wind to expose some of those feeding issues. As we trapped, we still found adults. The adults seem to be emerging over a longer period of time. So definitely are still seeing pressure. I think one of the reasons we maybe could have seen less here in central Iowa was the heavy rain that we had in early June. That 10 inches of rain we talked about in the last video could have actually drowned some of those larvae. In other places, the dry soils could have caused desiccation, right? As we have really dry soil, really deep cracks into the soil, we can actually cause those larvae to dry out as their outer layer of skin is kind of ripped open by soil particles, by sand, and obviously we had dry conditions that moved deep into the soil. So those both could have affected their mortality. Last thing I wanted to note was, in general, soil applied insecticide worked pretty well again. In most areas, we had enough moisture to dissolve that insecticide and create a nice zone of protection around the roots, but not too much moisture to wash it away. And here you see showcasing a picture that I took near Coon Rapids, showcasing some SmartStax Pro compared to a Chrome product. And we did still see differences in feeding in higher pressure areas, which is one of the benefits of using SmartStax Pro is for those acres. Northern corn rootworm pressure is something that I saw again this past year. So question everyone always asks is that extended diapause, which is something that happens in certain populations of northern corn rootworm larvae, where they will lay eggs and actually overwinter through a soybean rotation and come back up in corn the following year. I think there is more and more of this around, especially in northwest Iowa, and for me, it's in really 5 or 6 counties east of the interstate. So Iowa, Benton, Poweshiek, Jasper, Marshall, Tama. That area is where I really find a lot of both northern adults in rotated fields, but also where I see root feeding. And a lot of times it is low grade feeding, but a 10 to 15% impact on the roots can definitely still impact yield and standability and just overall stress, especially in a dry year. One question I get asked a lot is, what should we do about this? And a couple options. I think the most common sense one is to start to put out a little bit of below ground traits on those acres to identify how much feeding you're getting and see if you can quantify that. And obviously, of course, putting traps out is a great way to see if you're catching adults emerging. So I mentioned heat and drought stress earlier. These are some precip and some rainfall departure from normal charts that kind of show that, right? Through June and July, much warmer than normal, and also much drier than normal, with the exception of a few pockets in west central Iowa or up in northeast Iowa where they got wet and they stayed wet. But this caused some root issues to show up, right? We talked in the last video about planting a little bit too wet, having some compaction, and we can overcome that. We can overcome the rootless corn stage, but at some point we are going to need moisture. Corn roots do not grow and develop actively into very dry soil, and we started to see those issues show up, especially where we had roots only growing down the furrow due to sidewall compaction. So that puts added stress on a corn plant. Not just drought stress, but also nutrient availability is affected. And that's a problem when we get to pollination. And These are some pictures that I took from my area here in central Iowa. All of these were fields that I walked in, and all of them kind of had different issues. So if you start at the top right, where you see really just a lot of ear inconsistency, as some ears look normal, others have a lot more tip back and varying levels of kernel abortion. That was just variation down a row. The planting condition was uneven, emergence was then uneven. I think this field was due to residue, and that really showed up as we started to see those fully developed ears. The one in the middle, this was actually a part of the field that was too wet when it was planted and had really bad sidewall compaction. So you can see on the bottom side, some of those kernels did not pollinate, and you can see there's really just patchy and uneven pollination as we look across that ear. And then on the left, this was a field over by the Redfield area, which was one of the driest pockets of the state. This field had some spring manure applied and got really wet, was planted too wet, and this field really suffered. Made just over 100 bushels, just had a tough year overall. Mainly due to the weather. In a wetter year on this type of field, we should have had great productivity, but due to some of those issues, we saw some restriction in terms of how those ears filled out. And in the bottom right, this is a colleague, Jeremy Miner, who was noticing driving down the road 2 fields of the same hybrid planted about the same time, but one field was planted too wet, the other when it was fit. And that in that tweet, you see the dry corn, the really dry, dead-looking field in the bottom left. That was the field that was planted too wet. So really caused a lot of variability through the countryside. All right, so I've got a little exercise here when I talk about pollination stress impacting fields differently. If you've heard me talk, I've probably sounded like a broken record on this point, but it is very important. So we talked about varying planting dates early on. We had several different windows. The amount of stress that you had and its impact on yield, unfortunately, depended on when you planted and what maturity you planted. And I'm going to walk through an exercise here. This is a tool on the right you see that calculates growing degree days and kind of gives you estimates for pollination, for black layer. This is maintained. This is the High Plains Climate Prediction Center. I think there's one that Purdue runs that is more Midwest based. So what you do is you put in a planting date and a GDUs that would match up with a specific hybrid maturity. So this is a 107-day hybrid. I punched in those GDUs, and this is for Story County, Iowa. I picked a May 15th planting date. So based on the GDUs we accumulated this year, that May 15th planting date for a 107-day hybrid would have had a mid-pollination around July 19th. So then I went back and pulled the weather for that time period. This was out of a station in Des Moines in Polk County. And what you see is on July 19th through really the 23rd or 4th, very hot weather. Max temperatures during the day well over 90 and some warmer overnight temperatures as well. And that did have an impact on these hybrids, really sub 109-day, planted right around the middle of May. Corn does not like to pollinate at temperatures much over 85 degrees, and corn pollinates for about a week, but the bulk of that really happens in 2 to 3 days. So if temperatures are really hot during the day and also warm at night, what you end up with is pollination occurring only for a very small period of time during the day. As we string multiple days like that together, plus drought stress, plus maybe some nutrient stress because we have root issues, now we start to have some severe issues with pollination. But as I mentioned, it depended. So if we take that same May 15th planting date and punch in a 114-day hybrid, we get a little bit different result. We get mid-pollination on July 25th, right? We've got a fuller season hybrid. It's going to reach maturity a little bit later, or tassel a little bit later. Pulled the weather for that period, and what you see on July 25th is the high that day was close to 75 degrees. That's cool. And this week fell essentially during the week of Ragbri, if you can think back to that. If you remember that weekend and the week before Ragbri, it was horribly hot. And then during that week of the bike ride, we had really very cool weather in the mid 70s to the lower 80s, almost really cool overnight temps, dropping down into the low 60s. Just excellent weather for pollination for about a week. It took a while for those temperatures to climb back above 85 degrees. So again, you could have planted 2 different hybrids in 2 different fields on the same day, May 15th, and they could have been exposed to a completely different amount of pollination stress. Let's move to um, a later planting date. So that box is incorrect. It shows May 15th. So I punched in the same parameters, 107 day, planted on May 25th, and it moves that mid pollination window back to July 27th, right? So about the same time as that 114 day planted on May 15th. And again, that's what the weather looked like July 27th. Really very cool weather, pretty much below 85 degrees during the day and cool nights, which was very helpful for pollination. Now, if we look at that May 25th planting date for a fuller season product, and that's usually what we recommend. We don't recommend switching from a 113 to 114 in late May. Usually we have to get well into June before it's prudent to make that decision. So we planted that same 114-day hybrid on May 25th, so 10 days later, and it would have pollinated, that midpoint would have been around August 1st. When we look at the weather here in central Iowa on August 1st, what do we see? We see really warm conditions again. Daytime highs greater than 90, a couple days greater than 95, and we saw that same stress, or the stress affect these hybrids again. So it really depended on both the planting date and maturity, and there was not much you could have done about that. It was really just depended on timing and which maturity you were running this year. But we definitely did notice profound effects on pollination. Again, if you planted in early to mid-May, it was the 109-day and earlier hybrids, and if you planted in later May, it was your fuller season hybrids that bore the brunt of that pollination stress. Moving into disease, the big one that we saw in the state that everyone has talked about is tar spot. If you're unfamiliar with this disease, I've got a picture up here of it in the upper right. Really, that black spot that's kind of ingrained in the leaf. One tip I always give farmers is if you can't scrape it off with your thumb, it's most likely tar spot. So we definitely had it, but like last year, it came into central Iowa and western Iowa much later, and that was due to the weather that we talked about. So tar spot really likes leaf wetness, more than 8 hours of it, and during June and July and the first part of August, we just didn't have much leaf wetness. I could find some in fields in the river bottom or near creeks early in August, but for the most of my territory, it took until late August before we really saw it flare up. And it was kind of hard to put a finger on which areas were going to get it worse than others. If you look at the rainfall map, however, it corresponds very well with the tar spot map. So northeast Iowa, which in some places had over 30 inches of seasonal rain, shockingly, they had a lot of tar spot. One of the reasons it's so hard to nail down is because the pressure is variable. There are a lot of factors that affect how severely it infests, such as your inoculum load, our weather, whether you're doing tillage, your rotation, what stress that hybrid's currently going under, fertility, hybrid tolerances. So again, there are a lot of things at play here. One thing we learned is that fungicide applications were very effective, but the timing of when you sprayed, when the disease set in, your pressure, and also the product that you used affected how well your fungicide application worked. One thing that we know for certain is that multiple modes of actions and newer products seem to be performing the best, especially those that have a good dose of the strobilurin chemistry, as that seems to be the most active on tar spot. These are some slides from a couple years ago from Indiana that I wanted to showcase really quickly. And the point that I want to make on this one is this purple bar up here that you see at the top of this picture would be like a VT timing of fungicide. And as you can see, it lasts for a certain period of time, in this case, right around a month, and you can see that residual start to wear out. One thing I always want to call out is if we're only spraying once, we are going to see some tar spot later in the year once that fungicide wears off. And if you look at the tar spot's stroma severity percentage here, you can see once that fungicide wears off, it starts to go up, as there's nothing left protecting that plant. So in a sense, it's not about keeping from seeing zero tar spot. We are going to see some, most likely. It's a question of how long can we keep that infection at bay. And if it infects, can we push it back until that crop is almost near maturity, where it can have less of an impact on yield. I'd mentioned modes of action earlier, knowing that multiple modes of action are better than one. This is some data from Purdue that sort of confirms that. This data was from Illinois, Indiana, Michigan, and Wisconsin across some different environments from Darcy Talenko's group. And you can see that here, not only when you look at yield, right, of a non-treated or a one mode of action compared to a three mode of action product being significantly different, as you have the A here compared to the B here, but also the tar spot severity as you look at this graph, right? Non-treated versus one mode of action versus three modes of action. So 2 is better than 1, but 3 is going to give you the most protection. And lastly, this was looking at timing, and we've done some more work here recently, and that newer work kind of confirms this work from Purdue, which show that R2 and R3, the red arrow you see here, those timings provide the best and most effective control. That's when those fungicides finally start to wear off. If we spray at R2 or R3, as I mentioned, we're going to get some tar spot later. Those applications seem to push that, that infection that we are eventually going to get to much later in physiological maturity, as we start to see here, it wears off after R4 as we get into R5. So we're talking about dent as that milk line starts to move down. We've really already baked about 75% of that yield. So the penalty there, if some tar spot comes in later, is much less than if we're spraying at VT or prior to tassel. Just some anecdotal evidence. This was taken from a field in western Iowa, looking at 2 applications and where we really saw a big impact in yield from spraying fungicide, but the biggest jump was from untreated to treated. That second application in this case was probably profitable, but the biggest jump in yield and plant health was going from no fungicide to that first application. So that is something that we're still trying to collect more data on and research, what actually does the profitability look like from that 2-pass system. Some other diseases that we found in both crops. So in corn, we started to see some rust come in, and even some southern rust work its way up into central Iowa. Again, that one is blown in from the south, so it's primarily usually on field borders. And in my area, I usually see it a lot in complex with tar spot. If rust is there, it's kind of starts that process to make it easier for tar spot to infect. We also had some northern corn leaf blight come in really late. In late August, early September, we had that weather change, cool nights, a lot of fog and dew in the mornings, and I saw if a product was rated as below average on northern corn leaf blight, it definitely showed up with large lesions at the top of that plant. And there's a little fusarium crown rot around as well. It mostly affected those April planting dates, and as those seeds were put in some cool soils and had a more stressful emergence period. In soybeans, we actually saw some fusarium root rot set in. This is kind of more of a seedling disease or an early season disease, mainly from heavy rain falling and then hot weather coming in late June, and then a little bit of sudden death syndrome and brown stem rot. Not a lot out in the countryside, but we did see it in soybean fields here throughout central Iowa. In a lot of cases, we had like the root rot phase of sudden death syndrome, but we didn't get rain in a timely manner to move those toxins up to the rest of the leaves. So they may not have actually shown this disease in the field in the way that we're used to seeing it. For me, I primarily saw it in compacted areas of the field where we had wheel tracks, where a spreader ran in the fall, where there's a lot of field traffic at harvest. That was the main area where I saw sudden death syndrome. Just kind of one more note on fungicide use. We saw that fungicide positively impacted soybean yields, even where we didn't maybe have a ton of disease pressure from something like white mold. But I did hear a lot of people talk about it making harvest more difficult. We had a lot of green stems this fall and a lot of plants that really seemed like they didn't want to dry down. And fungicide can definitely make that a bit worse in soybeans. I think since a lot of our diseases came in late, the best timing again would have been around R2 or R3 in corn. If you sprayed pre-tassel, unfortunately, that may have helped from a yield perspective and kept some disease out, but you would have missed having protection at that key timing when that tar spot started to come in late August. And we're going to kind of cap off here with what August and September looked like before we close this video out. And again, as I mentioned, one of the biggest thing we had happen in August was heat. It was very, very warm in most of the state. I would say if you were south of Highway 30, and that paired with dry conditions caused issues. Rainfall did start to set in later in the month, especially in northeast Iowa, as you can see on this map up here. They got quite a bit of moisture at the end of August. And this really started to set the stage for what we would see at harvest. We talked about this a little bit last year. Corn stressed before pollination tends to slow maturity, but corn stressed after pollination tends to stress it and speed it along. And while we had some stress before maturity in July, really the month of June was pretty nice from a growing condition perspective. But late July and the first part of August was quite stressful. And that caused maturity to really start to speed. And I think what the learning from that was we saw some corn and even some soybean products finish early. They matured 2, maybe 3 weeks early due to those stressful conditions at grain fill. Some of those on the corn side, some of those ears were much smaller. They had tip back, they had abortion, so they had fewer kernels to fill. They started to dent prematurely and eventually black layer prematurely. And in soybeans, that stress affects it a little differently. That we see more pod abortion and flower abortion from stress after that flowering, which for soybeans is usually earlier in June, but as we get into late July, that stress really hits at a critical time, which is that R3 to R4 stage. Thanks for watching. You can check us out at Iowa_channel on Twitter. You can also find us at YouTube on the link below. And the next video will kind of cover a little bit more about the weather, but we'll really get into questions that I heard from farmers across my region and across the state, and we'll do my best to answer them in regards to what we learned about this year and hopefully what we can take from this year and apply it to next year.